Tonight, NASA has finally broken its silence. For the first time since the Mars flyby, the James Webb Space Telescope has released what officials are calling the first good images of 3I Atlas, the interstellar object that swept past Mars earlier this month. At first glance, the photos look ordinary, a dim white haze against a star field. But when analysts enhanced the color layers, something unexpected emerged. A structured glow, symmetrical, almost engineered. Webb was never meant to track a moving interstellar body, yet its instruments locked onto Atlas for nearly 20 minutes. The data it captured now has scientists stunned, and the public asking the same question. What exactly did James Webb see orbiting near Mars? It began as a quiet calibration test. Webb's mid-infrared instrument was supposed to capture reference frames near Mars's orbit, nothing more. But at 03:14 Universal Time, one faint target flickered into view: 3I Atlas. Engineers quickly switched Webb into high-speed tracking mode, something it had never attempted for an interstellar object. The telescope followed the visitor for exactly 19 minutes before it vanished beyond its line of sight. When the images were transmitted back through the Deep Space Network, scientists at Goddard were the first to notice the anomaly. In the unprocessed frames, Atlas appeared as a soft sphere wrapped in pale emerald light. But once the filters were stacked, a pattern emerged. Not random jets or dust trails, but what looked like concentric waves radiating outward, evenly spaced, as if responding to something unseen. The halo measured nearly 15,000 miles across, far brighter than models had predicted. And curiously, it reflected infrared frequencies that suggested metallic compounds rather than frozen volatiles. The discovery immediately raised questions. If Atlas is truly composed of dense reflective alloys, it would challenge everything we know about natural interstellar debris. Webb's sensors were detecting a material signature closer to titanium oxide and nickel-rich silicates, compounds rarely found in typical cometary nuclei. For the first time, astronomers were forced to ask if 3I Atlas might not just be a visitor, but a design. Under normal circumstances, James Webb should never have been able to capture 3I Atlas at all. The telescope was designed to observe galaxies billions of light years away, not an object darting through our own solar system at nearly 40 miles per second. Its instruments rely on extreme stability. Even a minor movement can blur a single pixel across thousands of miles. Yet somehow, Webb's optics remained locked on Atlas with precision down to less than 1/100th of an arcsecond. That precision baffles mission engineers. A senior systems analyst at the Space Telescope Science Institute quietly admitted that no current calibration explains that level of stability on a moving target. In other words, Webb's tracking system behaved as if Atlas itself was broadcasting a beacon, guiding the telescope's sensors toward it. The raw telemetry shows the object's position, data updating in real time, faster than Webb's predictive algorithms could have calculated on their own. It gets stranger. When researchers compared Webb's infrared data to simultaneous readings from the ExoMars Trace gas orbiter, both sets aligned perfectly, within fractions of a second. Two separate spacecraft, millions of miles apart, captured identical variations in brightness. That kind of synchronization should be impossible without coordination. NASA's official response has been brief. In a statement posted, then swiftly removed from its press site, the agency called the alignment a coincidental overlap of exposure sequences. But within hours, independent observatories across Europe began reporting the same pulsing signature, repeating every 43 seconds. A rhythmic oscillation that doesn't fit any known form of outgassing or jet activity. Some have suggested a natural explanation, resonance between solar wind pressure and the object's rotation. Others aren't convinced. The oscillations are too regular, too deliberate, and the silence from NASA isn't helping. Late last night, the agency's public data servers went offline for scheduled maintenance, halting access to the Webb archive just as researchers were requesting the new Mars region frames. For those following this story, the timing feels uncomfortably familiar. When something extraordinary happens, the images always vanish first. By dawn the next morning, the astronomy community had erupted. Forums filled with screenshots, cached datasets, and threads dissecting every pixel of Webb's missing frames. Then, without warning, NASA's open data portal went dark. a brief notice appeared. Due to ongoing federal budget restrictions, some public services may experience temporary downtime. To the public, that meant nothing. But to researchers watching in real time, it meant everything. The blackout began just 30 minutes after the last confirmed download of 3I Atlas imagery. Inside the Jet Propulsion Laboratory, technicians reportedly continued their work, but were barred from posting updates. Even NASA's usually active Twitter accounts went silent, their automated posting schedules disabled. Only one statement slipped through: "We are evaluating data integrity issues related to deep space imaging systems." It disappeared 10 minutes later. Meanwhile, signals from other Mars orbiters, Mars Express, MAVEN, and the Trace Gas Orbiter, were still flowing normally. Their instruments were logging something unusual, a burst of high-energy particles detected just minutes after Webb's observation. It wasn't a flare, and it wasn't solar interference. One telemetry analyst described it as a structured pulse, as though the object briefly emitted energy back toward the observers. That phrase, emitted energy back, spread like wildfire. Could an interstellar comet reflect data, or worse, respond to it? Scientists scrambled to explain the reading: an echo of cosmic rays, a glitch in radiation sensors, or perhaps interference caused by the solar wind. But none of those explanations aligned with the precise repeating intervals seen across multiple instruments. As the hours passed, NASA's silence began to feel calculated. Independent astronomers emailed for clarification and were told the imagery would remain under review until further notice. The phrase echoed past controversies: Oumuamua in 2017, Comet Borisov in 2019, both followed by mysterious gaps in official data streams. For now, all anyone could do was wait. In that waiting, the story changed shape. What started as a scientific observation was turning into something much larger, a question about who controls knowledge when discovery defies expectation. When the James Webb data finally resurfaced, through leaks rather than official channels, it came not as a polished press release, but as a series of unfiltered FITS files shared anonymously on a European astronomy forum. Within hours, image processors and amateurs around the world began reconstructing what NASA had refused to show. The composite they revealed stopped everyone cold. At the heart of 3I Atlas's glowing coma was a reflection that defied explanation. Under enhanced contrast, the object showed a central spine, straight, crisp, and perfectly symmetrical. The reflected light was not diffused like ice or dust. It returned in a narrow band, as if bouncing off a smooth, metallic surface. Even stranger, the intensity of that reflection shifted rhythmically, pulsing every 43 seconds, the same interval that had baffled Mars orbiters days earlier. Researchers at the European Space Agency attempted to reproduce the signal by modeling ordinary cometary materials. None fit. Frozen carbon dioxide, water ice, even nickel-iron mixtures all failed to account for the sharpness of the reflection. "We're looking at something with a surface coherence beyond natural fracture patterns," one analyst wrote. "It behaves like a mirror with purpose." Then came the frame that set social media ablaze. In one exposure taken at the 13-minute mark, a faint angular outline appeared within the glow, two parallel lines intersecting at a perfect 90 degrees. At first, many dismissed it as image noise, a coincidence of pixel stacking. But when the same pattern appeared again in an independent reprocessing by a Chilean observatory, the coincidence argument collapsed. Some astronomers urged restraint. Light scattering, they said, can create phantom geometries. Yet the geometry here didn't change orientation between frames, even as 3I Atlas moved against the background stars. It stayed aligned, as if fixed to the object itself. Meanwhile, James Webb's own optical calibration log hinted at something even more perplexing. During the observation, the telescope briefly switched into a backup alignment mode, usually reserved for communication satellites, not cosmic targets. That mode only activates when an incoming signal matches certain structural frequencies used for deep space telemetry. In other words, Webb may have reacted to 3I Atlas as though it were a transmitter. And if that's true, the reflection seen in those leaked images might not be light bouncing off its surface, but a response. Within 24 hours, the leaked images had divided the scientific community. At Harvard Center for Astrophysics, Dr. Richard Kluta convened a private roundtable with Avi Loeb and planetary physicist Peter Vess. Their goal was simple: to test whether the geometry in the James Webb frames could be explained naturally. But when they compared the Webb data to photometric curves collected by ground observatories between late September and early October, one pattern held steady, the same 43-second pulse. It was too precise to be random. Kluge argued for a conservative interpretation. He proposed that the rhythmic signal might result from rotational modulation, the way light glints from a spinning object with this irregular albedo. But Loeb wasn't convinced. If this were just a rotating comet, he told reporters off record, the modulation should smear as the coma expands. Instead, it's tightening. Meanwhile, NASA's Planetary Science Division insisted the images had been misinterpreted. A briefing memo claimed the reflection was caused by cosmic ray interference and algorithmic overstacking during independent reprocessing. Yet buried within the same document was an admission. The measured albedo of 3I Atlas was far higher than expected, nearly 10 times brighter than any known interstellar comet. That single line reignited the controversy. Because higher reflectivity means one thing, density, and density means mass. The heavier the nucleus, the less it's perturbed by outgassing. Data from the Minor Planet Center showed almost no non-gravitational acceleration in Atlas's trajectory, implying a core mass in excess of 30 billion tons, an object so compact it would rival metallic asteroids, not icy wanderers. ESA researchers pointed out another inconsistency. If the body were purely natural, its temperature profile should rise as it neared the sun. Yet Webb's infrared readings showed only minimal heating, as though the surface were resisting radiation rather than absorbing it. That thermal stability made little sense unless the material was conductive, perhaps even shielded. Publicly, NASA downplayed these findings, urging patience until further calibration checks were completed. Privately, sources at the Goddard Space Flight Center confirmed that new Webb observations had been requested, but classified under restricted access. To outside observers, it looked like a silent acknowledgement that something unusual was happening. And so, two narratives emerged. One side, led by NASA and ESA, clung to the belief that Atlas was an unusually massive, metal-rich comet. The other, smaller but louder, suggested it might be a fragment of something built, not born. For now, neither could prove the other wrong. But every hour that passed without new data only fueled the question no scientist wanted to say aloud. What if 3I Atlas isn't just visiting our solar system? What if it's observing? By mid-October, as the noise around 3I Atlas reached fever pitch, three competing theories dominated the discussion. Each claimed to explain the same set of impossible facts: the rhythmic pulses, the metallic spectrum, the stability, and the strange refusal of the object to heat as it approached the sun. The first theory, supported by most NASA engineers, insisted that Atlas was simply a natural interstellar comet. Extraordinary, yes, but not alien. They argued that the object could contain large deposits of nickel and titanium, elements that naturally reflect infrared light more efficiently than water ice. In this scenario, the symmetry seen in the Webb images was nothing more than a trick of perspective. A rotating shard of metallic rock, whose polished surface, sculpted by billions of years of cosmic erosion, happened to reflect sunlight in repeating intervals. It was a comforting explanation, one that kept humanity safely within the boundaries of known physics. The second theory came from the more daring corners of astrophysics. Dr. Avi Loeb described Atlas as a potential technological relic, not a functioning probe, but a derelict fragment from an ancient civilization. In a televised interview, he pointed out that the object's signal had remained coherent despite intense solar interference. If it were natural, he said, its rotation and jet emissions would quickly distort that pattern. But we see none of that. The emission is structured, narrow band, and constant. Critics accused Loeb of sensationalism, yet his argument found traction among younger astronomers frustrated by NASA's opacity. Then came the third theory, unexpected but elegant. Astrophysicist Suzanne Feiner proposed that Atlas might be neither debris nor artifact, but a seed. In her model, interstellar objects like Atlas are the embryos of planet formation, solid cores flung between systems to ignite new worlds. When such a body passes through a protoplanetary disk, It acts as a gravitational anchor, collecting gas and dust until a planet forms around it. We might be looking, she said, at the very mechanism that builds life from chaos. Her simulations, presented at the European Planetary Science Congress, showed how such a seed could survive ejection from its home star and remain dormant for eons before awakening under the heat of a new sun. The theory resonated with the Webb data. The metallic composition, the controlled warming, even the faint periodic signal. A rhythm not of communication, but of internal resonance, like a heartbeat within the stone. Between the lines of every paper and press conference lay the same unspoken tension. Whichever theory proved correct would reshape everything we know about cosmic origins. A natural body would expand our catalog of interstellar visitors. A relic would redefine the search for intelligence. And a seed, a self-assembling nucleus of creation, would suggest that life itself, that might not begin by accident, but by design woven into the fabric of the universe. As debates raged, the James Webb team prepared a second observation window. This time, the telescope would catch Atlas as it reached perihelion, its closest point to the sun, where its true nature could no longer hide behind dust or distance. On October 23rd, the James Webb Space Telescope turned its golden mirrors toward the inner solar system once more. The observation window was short, less than 20 minutes before the object disappeared behind the sun's glare, but the results would shake the scientific establishment to its core. The first set of frames arrived clean, stable, and brighter than before. Atlas had entered a new phase of activity. Instead of a chaotic tail of gas, its coma had expanded into an almost perfect sphere. Spectral analysis showed something no one expected: emission spikes across multiple discrete wavelengths, forming a repeating harmonic pattern. The peaks weren't random. They followed the same frequency ratios used in modern radio communication. For a brief moment, the data stream from Webb to Earth began fluctuating. The telescope's guidance sensors registered an input surge, as if receiving a signal rather than sending one. Engineers immediately switched to protective mode, fearing interference. But before the system safed itself, it recorded 6 full cycles of the pattern, each lasting exactly 43 seconds, separated by intervals of silence. When scientists overlaid those cycles on the object's light curve, the pulses matched perfectly with the brightness shifts previously detected by the Mars orbiters. Every separate mission, Webb, Trace Gas Orbiter, Perseverance, Mars Express, had recorded the same rhythm at different times, now confirmed in unison. The odds of 4 unconnected instruments detecting identical timing without coordination were mathematically near zero. Then came the visual anomaly. In the last composite frame before shutdown, Atlas's halo split, not explosively, but deliberately, forming a filament structure that radiated outward like an expanding grid. Each filament glowed with equal intensity, arranged in geometric order. For a fraction of a second, Webb's sensors detected a faint, collimated beam extending sunward before the camera saturated. NASA's internal Slack logs, later leaked by an anonymous source, recorded one line from a control operator at that exact moment. It moved, the object adjusted. No one outside the mission knew what that meant. Some said it referred to instrument drift. Others whispered that the object had changed trajectory, ever so slightly, but unmistakably against gravitational expectation. When the official briefing arrived 12 hours later, NASA described the event as data corruption due to solar interference. Yet, buried in a supplemental PDF, unnoticed for hours, was a single sentence confirming what no one wanted to admit. Post-analysis reveals a transient directional acceleration, inconsistent with natural outgassing. It was bureaucratic language for the unthinkable. Something near Mars had accelerated, on its own. By the time morning reached Washington, the story had already escaped containment. Leaked snippets of the internal NASA report circulated through encrypted astronomy forums, mirrored on Reddit, then picked up by mainstream outlets before noon. Each post repeated the same line: transient directional acceleration inconsistent with natural outgassing. The agency moved quickly. Press officers issued denials, labeling the leak as misinterpreted telemetry. Yet, within hours, independent analysts verified the math. The recorded delta V, less than 1/10 of a meter per second, was tiny but impossible to attribute to solar radiation or venting gas. The object, 3 billion miles from home and billions of years old, had made a controlled adjustment. Inside NASA's Goddard Space Flight Center, the tone shifted from curiosity to disbelief. A memo from the Deep Space Network Coordination Team described unexpected handshake attempts, a brief exchange of carrier frequencies detected when Webb's instruments went silent. Engineers confirmed it wasn't random noise. The waveform mirrored Earth origin communication structure, though reversed in sequence, as if echoing back our own call. That night, an emergency closed-door meeting gathered officials from NASA, ESA, and the U.S. Department of Defense. According to one attendee, the conversation was not about what Atlas was, but what to do next. The telescope would remain offline for instrument recalibration, and further images of the object would be withheld pending full spectral verification. In plain English, no more pictures. But science doesn't stop for silence. Across the world, observatories continue to track 3I Atlas as it slingshotted around the sun. Instead of fading, its coma contracted, the light curve stabilizing in a way that defied every model of thermal behavior. By October 26th, the object was already on its outbound trajectory, moving faster than predicted, yet without shedding mass. Then came the final shock. Late that evening, a private array in Chile detected a narrow-band radio spike at 8.1 gigahertz, the same frequency range used by Webb's guidance telemetry. The signal lasted 21 seconds and vanished. When plotted against the object's path, it aligned perfectly with Atlas's position. And then, silence. NASA has refused to comment. The James Webb team insists no active transmission occurred, but inside the astrophysics community, the debate has changed tone. No one's asking whether 3I Atlas is natural anymore, only who built it and why it came so close. Perhaps the answer lies not in its shape or speed, but in its timing. 2 interstellar visitors before it passed, unnoticed. This one arrived when our most powerful telescope was awake, staring straight at Mars. Maybe that's coincidence. Or maybe, as one researcher whispered off record, it waited for us to look. And now that we have, the question is no longer what James Webb saw, but what saw us. As the dust of speculation settles, one truth remains. No one can unsee what the James Webb Telescope revealed. In a universe filled with noise, 3I Atlas has spoken in silence, through geometry, rhythm, and movement too precise for chance. Maybe it is only a rock shaped by time and gravity, or maybe it's something older, patient, and aware. For now, the data is sealed, the questions unanswered, and the signal gone. But somewhere beyond Mars, that faint traveler keeps moving, tracing a path that began long before our species learned to look up. And perhaps, in the cold arithmetic of its orbit, a message still waits for the next telescope, the next observer, the next civilization ready to listen. Until then, all we can do is watch the stars and wonder if they're watching back.